Friends, welcome to UE learning classes managed by Modern English School Nevada. Dear students, myself Sujay Kumar, your mathematics teacher of Modern English School, New Area Nevada. A student, today I discuss some problems based on real number of exercise 1. First questions related to what is Euclid's division lemma or a state Euclid division's lemma. So dear students, I write on the board that is, it is Euclid division lemma. Let a small a be any positive integer divided by b. We get q is constant and r as the remainder. Again, let a be any positive integer divided by b. We get q is a constant and r is the remainder. Hence, when a is divided by b, we get q constant and r is remainder. So a is equal to bq plus r, where r is greater than equal to 0, less than b. It is called Euclid division's lemma. So when your question a state Euclid division's lemma, so you can write this statement easily. Next questions. A number is divided by 61 gives 27 as constant, 32 as remainder. Find the number. Again, a number is divided by 61 gives 27 as constant and 32 as remainder. Find the number. So it is a number divided by 61, we get 27 as constant and 32 is remainder. That means it is a dividend, and dividend is equal to division into constant plus remainder. Otherwise it is a, and a is equal to bq plus r. So a is equal to b 61 into 27 plus 32. Multiply, then you get 1647 plus 32, it is 1679. That is your solution. When you multiply 61 into 27, you get this is, and added to remainder, then you get this. Question number 3. That is, by what number should 1365 be divided to get 31 as a constant and 32 as a remainder? So this is the dividend. What should be divided to this number? That means this is the dividend. And what should be divided? That means what is the divisor? Your questions. If constant is given and remainder is also given. Your a is equal to bq plus r. That means dividend is equal to division into constant plus remainder. A is given 1365. Constant is given 31, but divisor is not given. I denote here divisor by b plus 32. This 32 plus goes this side, that is minus. Then 1365 minus 32, you get 133. It's equal to 31b. So what is b? Then b is 1333 by 31. So divide it by 43 times. So it is clear, divisor is 43. So b is equal to 43. Now see, find the HCF of 405 and 2520 by Euclid division's lemma. Dear student, this HCF I also solve in your examples. So first we solve this HCF by division methods as like in previous classes. So here is two numbers, one is 405, other is 2520. So it is clearly it is the divisor and it is the dividend. Larger number is always dividend and a smaller number is always divisor. So this is divided by 405. 6 times you get this, then remainder is 90. Now again divide, then 4 times 360. Now remainder is 45 and it is divided 90, so 2 times. So HCF is 45. But this method is called division method. But in your syllabus, you solve these questions by Euclid division's method. So you first solve by division methods and then arrange by Euclid's division method. By Euclid division method is equal to 2520 is equal to 405 into 6 plus 90. That means dividend is equal to division into quotient plus remainder. Next, what is dividend? 405. 405 is equal to 90 into 4 plus 45. Last, what is division now? 90. So here is 90 and it is 45 into 2 plus 0. And now remember 0. Hence, HCF is 45. Yes. So this method is called equilibrium division method. You solve this method only when you solve questions of HCF while division method, and hence arranged by equilibrium divisions. So remain questions you solve. Your question is 5, that is so that every positive integer is either even or odd. This question I solved in examples, example 2 or 3, but a statement that times is changed, that is in the form of 2m plus 1. But similarly this question you can solve by that method. So suppose let it is solution, let A be any positive integer divided by 2, we get Q is quotient, and R is remainder. R is remainder. So A is divided by 2, we get Q is quotient and R is remainder. Hence by equilibrium divisions A is equal to 2Q plus R, where R is greater than equal to 0, less than 2. So what is the possibility of R? So R is only 0 and 1. Because R is greater than equal to 0 but less than 2, so there are only two numbers, 0 and 1. So case first, A is equal to 2Q plus R, hence write 2Q plus 0, that is 2. It is 2Q and multiply by 2, so it is clearly it is even. Another case is 2Q plus R, and that is 2Q plus 1. Here 2 is not common among them, between them, then it is clearly odd. So there are two possibilities here, eitherwise even or odd. When 2 is common, 2 is multiple of that number, then this is even. Here is 2 no common between them, then it is odd. And option is only 2, because when any number divided by 2, we get remainder is only 2, 0 and 1. If you put the value 0, then it is clearly it is divisible by 2. When you put remainder is 1, then it is clearly it is not divisible by 2. That number divisible by 2, that is even. Which number is not divisible by 2, that is odd. So any number, if only 2 form, either even or odd. When it is form of 2Q, that is even. When it is form of 2Q plus 1, it is odd. So that's okay. Dear students, question number 6 and 7 of exercise 1A already solved in example. That is a number in the odd form, like as 4m plus 1 and 4m plus 3. Clearly this question solved in previous video of the example of this exercise. Similarly, next question 7, it is in the form of 6q plus 1, 6q plus 3, 6q plus 5. Otherwise 6m plus 1, 6m plus 3 and 6m plus 5. It is out. It is also solved by me in previous video of the examples of this exercise. So now I solve question number 8, and that is for any positive integers n, prove that n minus n is divisible by 6. So dear students, write here solution. Your question is n is positive any integers, like as 1, 2, 3, 4, 5, 6. When you put here, then it is clearly, like give here some example, like nq minus n. Suppose n is 3. So what you get? 3q minus 3. 3 3 is 27 minus 3, that is 24. then it is clearly it is divisible by 6. Other you take as a 5, n5, that is n5 cube minus 5, that is 125 minus 5, that is 120. It is also clearly divisible by 6. But your question is why? Give reason why n cube minus n is always divisible by 6. So you write the solution. You write n cube minus n. So if I try take n common, then it is n square minus 1, that is n, and it is n square minus 1 square. Hence it is equal to n minus 1 and n plus 1. You arrange it, n minus 1, n and n plus 1. To find out, these are the all three consecutive number. So n minus 1 first number, second number n, third number n plus 1. And we know that three consecutive number, a positive number, positive integers, is always divisible by 6. You take any three consecutive positive integers, like as 8, 9, 10. Three consecutive positive integers, then 8 into 9 into 10. It is 720. It is clearly divisible by 6. You write 2, 3, 4. It is 2 into 3 into 4. 2, 3 is 6, 4 is 24. It is always divisible by 6. So your question is n minus 1, n and n plus 1. So you write these are three consecutive positive integer, hence it is divisible by 6. Clear. So you first factorize it and then you write these are three consecutive numbers, and we know that any three consecutive positive integers is divisible by 6. So this number is also divisible by 6. That's all. Question number 9 of exercise 1a, that is prove that if x and y are both odd positive integers, then x square plus y square is even. That means it is the multiple of 2, but not divisible by 4. That means it is not multiple of 4. If x and y are odd and both are positive. Dear student, odd number in the form of 3 number, like as you write 2m plus 1, it is odd. Sometimes you write 4m plus 1, 4m plus 3, odd. You write 6m plus 1, 6m plus 3, and 6m plus 5 is odd. There are 3 conditions in your book events. These types of number are odd. Sometimes at the place of m you write q, no problem. 4q plus 1, 4q plus 3, etc. So there are 3 conditions. So in these questions you take this condition. These 2 numbers are in the form of 4m plus 1 and 4m plus 3, because when you take 4m plus 1, then it is possibility to take common 2 or 4. So you write let positive odd integer is 4m plus 1 and 4m plus 3. So your question is x square plus y square. Then first integer is 4m plus 1 square plus 4m plus 3 square. What you get here? Here is a square plus b square plus 2 into a into b plus a square plus b square plus 2 into a into b. At the place of a is 4m and place of b is 3. Then it is 16m square plus 1 and 4 to that 8m plus 16m square plus 9 and 4 to the 8 3 the 24m. Now arrange their like terms. 16m or 16m, that is 32m square, and 8m 24, that is 32m, and 1 plus 9, that is 10. Dear student, what is the common among them? It is clearly 2. So it is 16m square plus 16m plus 5. So it is even because it is the multiple of 2. Each term has 2 common. Then it is the multiple of 2. So it is an even number. But it has no common 4 among them. Find out. Here 4 is common, there 4 is common, but it has 10. It has no 4 common. So we write, but it is not divisible by 4. But it is not divisible by 4. So your question is, if x and y are odd integers, then x square plus y square is even. It is clearly even because 2 is common among them, but it is not divisible by 4 because there is no common among them is 4. So you write it is divisible by 2, but it is not divisible by 4. That's. This is the last questions of the exercise 1A. Question number 10, that is use Euclid algorithm to find HCF of 1190 and 1445. Express the HCF in the form of 1190m plus 1445m. Express in the form of this. This type question I solved in also in examples. One question are there and other questions of the last in exercise. So first this type question, first to find HCF by Euclid division methods. But Euclid division methods, first we find HCF by only division methods. So here is 2 number 1445 and 1190. This is greater and this is a smaller. So always greater is the work and dividend. It is the division. So divide it. Remainder is 255. Again this is work as a dividend. Then now remainder is 170. Now this is work as a dividend. Now remainder is 85. Now this is the dividend. 2 times 170. So 85 is the HCF. So it as the previous classes, class 5, 6, 7, we find the HCF by these methods. So first we find the HCF by division method. Then arrange this HCF by Euclid's methods. So by Euclid's methods, you write here 1445 is equal to 1190 into 1 plus 255. Next 1190 is equal to 255 into 4 plus 170. Next 255 is equal to 170 into 1 plus 85. Plus to 170, it is 85 into 2, that is plus 0. So now remainder is 0, hence HCF is 85. If HCF is 85, then your questions, you arrange the HCF 85 in the form of this. That means, what is the value of m and n in this equation? Then when we put it, and you get the HCF 85. So now see this time. Here. So your answer is 85. How you find 85 from the solution of Euclid? So 85 is here and there. Here if 85 get, then you get 85 is equal to 85 because 2 divide here, then 85 is equal to 85. So don't use this. So now you find 85. What is the value of 85? It is 255 minus 170 into 1. So write here 85 is equal to 255 minus 170 into 1. From here, because HCF is 85. So find HCF. 85 is equal to 255 minus 170 into 1. I write here 170 into 1. Next step, 255 minus, what is the value of 170? It is the value of 1190 minus 255 into 4. I write here 255 minus 1190 minus 255 into 4 into 1. Here is 1. Solve it. It is 255 minus 1190 into 1 minus 255 into 4. Here is minus and there minus, so minus minus plus. Now arrange it. Here is 255 into 4 and here is 255. Then it is clear 255 into 5 because here is 4x, here is x, then 5x. So you write 255 into 5 minus 1190. Last step, what is the value of 255? 255 is equal to 1445 minus 1190. So I write here 255 is 145 minus 1190 into 5. It is 5. So I multiply here 5. Solve it. It is 1445 into 5 minus 1190 into 5 and minus 1190. Then it is 1145 minus 1190 into 6 because 1190 here and 1190 to 5 is there. So here is sum on 1, here is 5, so it is 6. So 1190 into 6. Now 85 is equal to 1190 into minus 6 because here is minus. So minus convert into here. You can also write that 445 into 5 plus 1190 into minus 6. Then you arrange it. Now we write 1190 into minus 6 plus 1445 into 5. And your question is 1190 m plus 1445 n. So what is the value of m? Comparison between them. Then you get m is the minus 6 and n is the 5. So your solution is m is equal to minus 6, n is equal to 5. Then when we put here minus 6 and 5, then you get 85. So very important question for the board of examinations. So dear student, we solve these questions 1 or 2 times. Thank you.